Evaluate the integral of x cubed over x squared minus 2x plus 1 from -1 to 0. The very first question you have to ask yourself is the degree of the numerator greater than the degree of the denominator, greater than the degree of the numerator? And the answer here is no. This causes extra problems because of algebra that we need to do to even get this problem started. When the answer is no, then we're going to have to long divide to make it so. So, long division, we have to take the denominator and divide it into the numerator. If there are missing terms, we should fill them in with 0 coefficients. And then you ask yourself the question. You take a leading term of each. You have x squared and you need x cubed. What do you need to multiply in order to get it? What do you need to multiply by in order to get it? Well, we need to multiply by x. So that goes up top here. And then you distribute that to the other parts that are on the outside. Multiply it out. Get x cubed minus 2x squared plus 1 times x. Now, what you have to do is subtract that. I like to do it the following way, by putting a minus sign and putting parentheses around the whole thing. Okay. And then when I subtract, you have to be careful. This is 0 minus a -2, so that's 2x squared. 0 minus 1x, or negative x. Great. Bring down the 0. And then ask yourself the question again. You have x squared and you need 2x squared. Focus on the leading term. You can do that by multiplying by 2. That thing that you multiply by goes up top, and then it's your job to distribute that across to the terms that are on the outside, and end up with 2x squared minus 4x plus 2. Once again, you need to subtract. My recommendation is to put parentheses around it and put a minus. And when we subtract, we get a negative x plus a 4x. Negative x plus a 4x. You know what that is. That's a 3x. And then 0 minus 2, that's a -2. And so, this is the end. How do you know when you're done? When the degree of what you have as your original denominator is more than the degree of where you're at the point, that part of the long division. That's when you know you're done. And how do you write the answer? This here is basically the part that's not part of the fraction at all, and then the fraction comes in taking your remainder and putting over what you were dividing by. So our original integration becomes x plus 2 plus the fraction of 3x minus 2 over our original denominator of x squared minus 3x, minus 2x, plus 1. All right, great. So now what? We need to set up the method. The method is ready to start now. So what do? Well, we need to factor the denominator. Okay, well, we go to do that. The denominator is x squared minus 2x plus 1. That factors as x minus 1 and x minus 1. But it's best to call this x minus 1 quantity squared. If we were to leave it as x minus 1 and x minus 1, our partial fraction decomposition will go wrong. Okay? And here's why. It's our job to recognize which of the 3 types of terms we have. There's only 3 types of terms that the denominator could have. The denominator could have a linear term that's raised to the first power. The denominator could have linear term that could be possibly raised to higher powers. Or thirdly, the denominator can have an irreducible quadratic term. So what are we looking at? It is a linear term that is squared, that is raised to a higher power. This gets handled a certain way. Each one of these guys gets handled differently. And so how do we handle when we have a linear term that's raised to a power of 2? Well, when we go to decompose, we have to basically decompose in the following manner. We have to take and have a fraction for each power of the denominator. So we have an x minus 1 squared as the denominator of one fraction, and an x minus 1 to the first as the denominator of the second fraction. These coefficients, though, and the numerators of these guys end up as just constants. So we have decomposed it. And now it's our job to chase down the constants. What is A and what is B that will make this happen? And pretty much you focus your attention on the fraction part, not for the sake of the other part. You're not going to ignore this. We'll come back to this. But we need to focus our attention on the partial fraction decomposition part. And then we'll come back to the other part that has the x plus 2. So how do you get, well, you make a common denominator, but the common denominator is x minus 1 quantity squared. So the first fraction doesn't need to be multiplied by anything. It has x minus 1 squared as its denominator. The second fraction, b over x minus 1, is missing a power of x minus 1. So you multiply b by x minus 1, but you leave a alone. You have your original numerator of 3x minus 2, and you have your denominator once you are to put these two fractions together. A gets left alone. There's nothing to multiply that by. It's at this point where we have to choose values of x. But the smart choice would be to choose values that would make the original denominator 0. Here, that would be x equals 1. What it does is it kills one part of the whole calculation, and you only get the other part. So when we let x equal 1, we'll have 3 minus 2 on the left-hand side, and the b term would go away because of the fact that it has this x minus 1 term in it. This guy would 0 out. So we can quickly say that a is 1 because we have 3 minus 2 is equal to a, or a is 1. Okay, great. A is 1. But then we run out of things that would make our denominator 0. So in this case, then we pick other numbers that are easy to plug in. We've already used 1. 0 is a good choice to plug in as your first choice of convenient choice. It's not the the ultimate choice that will kill out terms, but occasionally it does. But it is very easy to plug in 0. To evaluate things at 0, we just sort of take the terms that have x in them and they go away. We have a negative 2 on the left-hand side, and then the x here goes away, and we're left with the negative b here. Basically, a minus b should be negative 2. We know a. We know that a is 1. We could plug that in. Okay. Ship the 1 over to the other side by subtracting it. We have negative 3 is negative b. Well, that means the b is 3. And we have our a and b. Great. We chase down the constants. The last step is to put it back together and do the integration. So we put it back together. We put the 1 over the x minus 1 quantity squared and the 3 over the x minus 1. Both guys were positive. Great. Now here's the key, though. You can't forget about that other part. Remember, the x plus 2 is there. It's part of the long division. It's going to be part of the integral. It's part of the original fraction. Now, how are you going to integrate? So you can just take a glance here. X you can integrate. 2 you can integrate. Even this last guy, 3 over x minus 1, you can integrate without too much trouble. This guy is a bit of trouble. Don't be deceived by it. It's not as easy as it looks. In fact, to really do it, let's go ahead and look at a u substitution. If we let u be x minus 1, then du is just dx. And we're looking at 1 over u squared, du. That's not a log. You have to treat that as u to the negative 2. The antiderivative of that is u to the negative 1 over negative 1. Simplifies to be negative 1 over u. And so, that is what the antiderivative of that's going to be. Now, in general, though, if you have, nothing special about the 1 that's here, so maybe you can put this in your cheat sheet if you allow one, that when you try to integrate the quantity of x minus 1 squared in the denominator and a 1 in the numerator, then it just becomes negative 1 over x minus k. Okay. Great, so we have that guy integrated. That's after integration. So we go and integrate these guys, and we have x squared over 2. We have 2x. We have that guy minus 1 over x minus 1. And then we have 3 log of x minus 1. Our limits of integration are 0 and 1. So we put a 0 in, and we put a 1 in. Putting a 0 into these first two terms just doesn't contribute. And in these other two terms, this guy is just going to be basically a 1. This will be a log of 1 after absolute value. Over here, be careful, it's a negative 1. So we'll get a half. We'll get a minus 2 here. A minus 2 in the denominator here. And then a minus 2 inside of a log here. All right, great. Well, after the absolute value is taken care of, what we're looking at is a 1. 3 log 1, we know, we don't care about that term. It's log of 1 is 0. This is the positive half, be careful. Minus a 2. And then here's another positive a half because of this double negative here. And this is just, I don't know why I didn't take that out. That's just a log of 2. Okay. So, now, the only thing that's left in the first part is a 1. We have a half, and we have a half. That's a 1. 1 minus 2 is a negative 1. And then when we go distribute across, it becomes a positive 1. But minus a 3 log 2. For a final answer of 2 minus 3 log 2.